Yeah, I welcome you to the next panel, to the panel of cutting, disassembly, and removal. I'm Marcus Benton. Maybe you saw me at 10 o'clock, so I'm the Dean of the Maritime Faculty of the University of Applied Science Leer, and one of the responsible persons of the Decom Tools project. My background is a naval architect, and therefore I was very happy to see some big vessels in the last panel. So that was great. But we saw also that time is running fast. So the next panelist, it's about a complete removal of monopiles with Vibro Lifting Tool from Cape Holland. Dick has entered the offshore industry 7 years ago when starting at Cape Holland. He is an automotive engineer and started work life in the UK. And he stayed for 15 years before returning back to the Netherlands. Dick has dedicated his time at Cape Holland to the introduction and promotion of the vibratory technology to the offshore market. After many success stories in the offshore oil and gas markets, the offshore wind market is now also starting to see the many advantages of Cape Vibro Lifting Tool, including the opportunities for the decommissioning projects. And I think that is a very important point when it comes to the question, have we to leave the monopiles in the seabed or can we take them out? And I guess you can give an answer to this, Dick. The floor is yours.
Good afternoon. Thank you for inviting me to this conference, and I think we can hopefully answer the question that Emmanuel was asked if they can remove the foundations, which is something that we hope we can do. And thank you for the introduction, Marcus. I won't go through that then. So really, first of all, hold on. I had the question, and I think it's been answered already a few times yesterday and today, but I'll just go through it again. Why do we want to remove the offshore foundations completely anyway? Well, first of all, it's for the field owner. It means he has no longer an ongoing liability, which as long as there's steel in the ground, they have. Furthermore, we want to reuse the materials. Was mentioned yesterday as well that there's a large part of steel in the foundations and it's easily recyclable. So why not? If we can take it out, let's take it out. It also means we have no further future limitations for the use of the seabed. That's also discussed yesterday for repowering or anything else we might ever want to do with the seabed in the future. Because once the piles are cut off, which is the common practice now below the seabed, and they would have to be removed in the future, it will just be very expensive and a difficult operation to do. And last but not least, as we all been brought up probably, it's good practice to clear up your mess after you made it. And I think we can learn from the past that it's not wise to leave it up to future generations to do the clearing up. And as an example, I just show you these old photographs where at the time after the war, it seems like a good idea to just get rid of all the ammunition by just dumping it at sea. But now also with the installation of the wind farms, it's just causing problems for us. And because of time and decay, it just becomes a lot more expensive operation to remove now if we have to. So I think that's a similar thing that we can see with the foundations for the offshore wind farms as well in the future. A quick introduction of Cape Holland, because not everyone might know us yet. We're a company based in the north of Holland, an hour south of Eemshaven port. We're established in 2002 and run by the 6th generation of piling family. We're a global leader in the offshore vibro technology, and we're manufacturing our tools, but we also provide them out as a service provider. We supply them to contractors like Jan de Nul, for instance, with all the auxiliary equipment and personnel that's needed for using the tools. Now, a quick explanation of what the Vibro Lifting Tool is exactly. I won't go into the details of how it works exactly, but basically it's a vibro hammer, which has been a tool used onshore for many decades already. and it's combined with a certified lifting tool for offshore lifting. It basically contains of a lifting structure, which we can also use for upending of piles, the vibratory hammer, which is similar to the units that are used onshore, but then a lot larger and also adapted for the certification for the offshore lifting. Furthermore, there's a base frame, which the vibro hammer connects to, and then underneath the base frame, there's hydraulic clamping system. And the important thing here is that the base frame, we can easily swap out and use a bigger base frame with more clamps to use for bigger piles. So it's very scalable, even to the very large XXL monopiles. Diameters of over 10 meters should not be a problem. The record for a diameter of a pile being installed with vibratory hammer is 30 meters diameter at the moment. Furthermore, as you can hear already, it's a commercial available product, so we're not still in development stages, and it can be used. To give you a quick idea how it would work in practice, very simply graphical shown. First of all, and I'll do it for the grouted transition piece onto the monopile, as well as for the bolted transition piece, or even what we're going to in the future, the TP-less monopiles. So first of all, Emmanuel does his job. He removes the tower and the turbine itself. And then we're basically left with the transition piece and the monopile. And in case of the grouted transition piece, it should be cut below the transition piece, because we haven't got any experience yet if we start vibrating on the grouted TP, if the TP will just come loose or if the whole lot comes loose, but there's some investigation to be done in the future. But once it's cut, it can be done anywhere below the TP and above the seabed. We basically place our tool on top of the pile, and the hydraulic clamps either go on top of the cut pile, or we have special flange clamps that could clamp on the flange of the transition piece, or if the transition piece is removed, in that case, it can also clamp on the flange of the monopile. What we do next is we turn on the vibro, and we wait a little for the pile to loosen. And once it starts loosening, we basically just start lifting with the crane vessel until it's out of the seabed. We turn off our vibration unit, and then we lift the pile to deck, where we down end the pile instead of upending, which we normally do with the installation. And we can put it in its transition piece position on the deck, can be C-fastened, and we can go up to the next pile. So this is all done in one operation. So what are the advantages of using this? Well, first of all, it's a very fast operation. We will see in video later on in the presentation. There's not a lot of preparation to be done. Also not to the seabed. We don't have to start dredging out or anything like that. We can just place the tool on top of the pile, turn it on, and start extracting the pile. As I just showed you, it's a single operation, so no interference of divers or any tool changes, or no need for holding the pile on the side of the vessel to weld holes into the pile, so you can put your rigging on that to then extract the pile. It can all be done in a safe manner. Very little environmental impact, because we don't need to do the dredging. The pile can just be taken out and the seabed can be left in place. And then, of course, depending if the scour protection needs to be removed, then there will be some environmental impact from removing the cables, but that will be no different than from leaving the piles below the seabed. Other thing, it's suitable for subsea operation, which of course is handy when you need to do a cut below the water line. But also for further futures, when even we have to start decommissioning floating turbines, they can be used for extracting piles at sort of say more than 100 meters depth that have been used for anchoring floating vessels, floating turbines. One of the disadvantages of using the tool, it does require a heavy lift vessel normally with sufficient crane capacity to be able to lift the pile, the tool at the same time, and have a little bit of extra power to lift it up as well. So what Has it been used for already? It's already a common use tool. I mean, on land we use it a lot for extracting sheet piles. It's common, done every day. But here I just want to show you some examples where we do it in the water. First of all, the tool has been used a number of times for removal of damaged piles in ports, where a vessel might have collided with a mooring pile and it needs to be fixed. So we take it out, drive in a new one, and we're good to go. We've done a few projects where we've done soil sampling using a vibratory hammer, where we installed the pile, and there's a closing mechanism at the bottom. We would extract the pile again, and then we would have a nice soil sample for further lab investigation. A very common use for the Vibro tool is also in the oil and gas market for laying gas pipes and oil pipes, where a pile is needed as a reaction pile to hold the pipeline in place while it's being laid. So we can use the Vibro tool, first of all, install the pile, and once the pipeline is laid, we go back to the position, extract the pile, and go to the next location for the next run of pipeline. So it's obviously very easy to use for that. And another use we use it for more and more is actually, for instance, on the installation of mooring spreads for FPSOs. Quite often the mooring piles there get driven to below the seabed, and that's been done with a follower, which you can see in the foreground on this picture. But the downside of that is that the follower may go down with the pile to, say, 4 meters below the seabed, and when they want to extract it with the crane, it gets stuck because it's just jammed in there, and the crane capacity is not sufficient to pull it free. We can put a Vibro hammer on top, loosen it, and easily withdraw the follower from the pile. Now, what about the monopiles? Because that's really what we're here for the decommissioning project. Well, we've done a few. First one we did was a dot turbine test on the Maasvlakte, where a pile was installed 15 meters into the soil, purely using the our Vibro lifting tool, free hanging from a crane. Installed 15 meters into the soil. Then there was a turbine placed on top, and all the tests were done. And 7 months later, we came back to basically extract the pile again, and leaving the surroundings pretty much as they were found. And what happened next in 2018, actually that same pile was lengthened with another 30 meters and was then installed on the Amalia wind farm in Holland with the A-gear from Herema. It was a sort of double test, once to test the slip joints between the pile and the turbine on top. And secondly, it was also a test to be able to see what we could do with a free hanging vessel at DP mode, dynamic positioning, to install the pile and to reach a certain verticality that was required. Well, and to test that, we've installed the pile actually 3 times and extracted it twice. And the pile is still at the Amalia field at the moment and will be extracted later this year, again in the next campaign. The last one I want to show you, you can actually see here we have a larger Vibro, a multiple units, got 2 Vibros on top of a bigger base frame. This pile is 6.5 meters long, 6.5 meters diameter, about 60 meters long. And this was used by Seaway Heavy Lifting to test a motion compensated gripper in the North Sea. And here the pile was installed, left for a few days, and then came back to extract it again and do another installation and extraction after that, purely to see how the motion compensator would react during DP mode installation. So obviously a very interesting project for the motion compensated gripper, but for us also to be able to show the installation and extraction capabilities of our Vibro lifting tool. Now, as I mentioned before, I would show you a video. This is actually a clip of the installation at the Maasvlakte. Obviously, it was, although it was installed from water, it was installed on land, but it gave us a good opportunity to make some nice footage. So I want to finalize my presentation with showing you how this was done. And I hope you can see it in the background. It's the pioneering spirit, so nice with the decommissioning theme we have. So the Vibro is here in its park stand. It's being lifted on top of the pile. remotely clamped with the hydraulic clamps. And once it's in place, the vibro is started, the crane starts pulling, the pile comes out in a nice, clean, smooth operation. The total extraction took 11 minutes to clear it completely free from the soil. And then afterwards is down-ended, the clamps are released, the tool is taken off, put it back into the vertical mode, and then placed back into its frame, which normally obviously would be on the deck of the vessel. But that's really it from start to finish in one nice movement. And I hope it's given you a good example of how this also could work offshore with bigger piles. And that was my presentation. So I'd like to thank you for your attention, and I'll be happy to get any questions.
Thank you, Dick. You can be sure there are a lot of questions, but
Okay.
I would like to shift this to the question and answer section after the last presenter gave this presentation. So that was really interesting. Thank you for your presentation. And for those who have questions, please write in the question window, and we will present this then to the panelists afterwards. So we have now Jan Suleiman. So I think he fits now very good into this presentation panel. We had one who is presenting how he can climb up on the towers. We have now one who is telling us that there's no excuse anymore to leave the piles in the seabed. And now we need one who is able to cut. And there we have now Jan. He is an expert since 9 years, sales director and partner at Müller-Opladen. They usually make CNC pipe flame cutting machines, including the robot technology hosting the cutting machines. But they are also good in welding systems, but today is about cutting. And before Jan worked for Müller-Opladen, he worked for Messer Griesheim, selling plate flame cutting machines to the wind industry. And so I think he's now the expert telling us things for cutting and welding. So I would like to say the floor is yours. Please.
So that's a very short introductory video about our products, our company, that you just get an impression what we are doing. I think a 1-minute video is always good, so people get a little bit an impression what we're talking about before I start the more, let's say, a little bit more dry presentation. So we do all kinds of cutting, robotic cutting, and as well mainly pipe cutting, as already said, as well very big pipes. And we work a lot with the offshore industry, whether it's for oil rigs or for offshore wind towers. It's for us pretty much the same. So I think we're fitting well into this panel here. But I have to acknowledge, so far we were working almost exclusively on the construction of offshore wind energy stuff and not on the decommissioning. So that's a little bit new, but I think we can bring some things to the table here as well. I would try to shift now to my actual presentation. I don't know what you see now or you don't see.
We see a blue screen.
Okay. How do we change this now to the presentation?
Do you have your presentation open on your computer?
Yes, it's open on my computer, yes. Correct.
I'm just going to send it back to you so that you can choose the correct screen to share.
Okay, yeah, that might be the one. Okay, so that was the mode we tried yesterday. It would work. Okay, you see now the presentation?
Yes, we do. You're good to go.
Okay, all right. Well, that's presentation about Müller-Opladen and our American factory, Watts Müller. I'll go relatively fast through that because we have only 15 minutes. Müller-Opladen is a more than 100 years old German machine building company third generation, a lot of tradition and experience in machine building. We joined in 2016 with the American market leader for CNC pipe profilers, Watts Müller. So our core or main product is actually CNC pipe profiling. So that's where we come from, and we do this for many, many years, and we have built more than, together with Watts, almost 2,000 machines worldwide in 80 countries. Just a few ideas. Well, our average export level from the German factory is more than 75%, so we are very, very international. Our American friends or partners are doing a little bit of export. They have a giant market in their own country, so they're not so export depending. Maybe just an idea, average annual turnover of both factories around 15 million US dollars. We are in both factories together 50, 60 persons. We have a very high skilled qualification level of our employees, so more than 30% of our guys are with university degrees. And we are, let's say, small, flexible, and very innovative. Selected corporate milestones. So we built the worldwide longest machine for cutting of more than 30 meters pipe. That's Dragados Offshore there as well in the offshore industry, obviously. We built the worldwide biggest machine with full automatic logistics. That's regarding pipe cutting. And with Novatec, the last milestone here, we got an $3 million order from Russia for 6 machines, and they will dedicate at least partly as well to offshore. We have 2 locations, as already said, Opladen, Germany, in Leverkusen near Cologne, and the other one is in Puyallup, Washington State, near Seattle in the US. Our key products are 3D pipe or 3D profiling machines, and we do as well a lot of automatic welding systems. So what I see here for the decommissioning, I see a certain kind of hybrid action between cutting, because we will need cutting, but we'll use basically standard applications or standard customized applications from our welding sector. Just to show you a little bit welding. So these are really customized welding applications we have successfully sold and installed worldwide. So we are very international. I already said this. What is one of the core things here is customer-driven planning and CAD design. So we really design our machines from scratch in any aspect. We do as well all the electrical planning, the software, the integration of CNC and PLC things, human machine interface. So that's all in our hands. So we can really adapt to customer needs. If we talk then about sensing systems, so we have electrical mechanical tracers in the cutting machines. We have laser sensors in the cutting and welding machines. So we have a lot of sensing experience as well, which might be needed in terms of getting these things done. Just one flashlight here to one of our biggest machines. That's a 4-meter machine. It's in the heavy duty line, so it already says it's for big stuff. This machine, as it is here on the picture, is in Samil Steel, Saudi Arabia. So you can see the operator has a motorized cabin which goes up and down. As it's in Saudi Arabia, very hot, the customer wanted an air-conditioned cabin for the operator. So we realized what the customer wanted. It's a patented system which gives us the opportunity to cut the vessel. That means the cylindric part, which is basically a big pipe where all the nozzles and the pressure vessels sit in, or this could be as well an offshore pile. And we can then hydraulically bring the chuck down and cut as well the domes or the tank heads, as you see on the right side picture. This system is patented, so we have a very good position on that. I show you this just to show you that we have a lot of experience and innovative things, and we can basically build anything which is somehow the technical challenge to build now. I think the right cutting technology will be oxy-fuel cutting. So we have a lot of experience in oxy-fuel cutting with automatic piercing and automatic preheating, which comes into the section automatically. And so I think we are very well equipped for that. We do as well plasma cutting. We have a lot of experience as well in plasma cutting if there would be any need to cut stuff which is not carbon steel. So that means stainless or aluminium or even things like titanium or cladded stuff. We cut this with plasma. We have the experience. We can use that technology as well. Basically, I think in decommissioning wind towers, it's carbon steel. We have as well small and economic solutions which are for simple cutting tasks, so we can use the whole experience as well on simple applications and simple stuff in order to get something going in the field to cut the piles the most economic and the easiest way. Now, automatic welding system. So what we do here, what you see here, this is a column and on the left side, column and boom multi-axis system. That's PLC driven, and it's MIG-MAG welding. It's actually for oil and gas valves. And we have a multi-axis positioner. That's a 1-ton application. And what you see on the right side is basically a very similar system, but it's a 15 tons application. So we do all this stuff customer driven, and we have this, let's say, in many applications. Now, to show you as well a little bit what we do in welding as well, we have a circumferential welding system there. It's submerged arc welding for fittings, and it's under high hydraulic pressure. So that was the core thing there, was that the customer needed to weld these parts under a high hydraulic pressure. So we built something customized for him. What you see on the right side is a welding system for building up welds on drilling heads, which are used for natural gas drilling in the North Sea. That's as well a pretty customized and specialized system. So we are very used to build customized applications. What we see here now is an automatic welding column and boom welding systems on the left side. At the end, we have already installed at Siemens for the German high-speed train, the ICE, 3 of those very big welding systems, 40 meters long, very complex welding application. So we do all this stuff customized. And we have the base frames, which are column and boom designs. We have a lean design and we have heavy duty design. For the application I have in mind, I think we will use the heavy duty thing, which can go up to 12 or 15 meters height, and we can have a boom in a way of 12 meters wide. So I think we are good there on that. So just a few customer references. Alstom Germany, you see a complex welding system with big column and boom. CB&I USA, that's the world's biggest machine with full automatic logistics and pipe cutting up to 45 foot or 13.8 meters, 36 metric tons on the pipe side and 2 meter diameter. COC in China, it was Asia's largest machine when it was installed. I think it still is. That's Dragados Offshore in Spain, as already mentioned, 30 meters cutting length. That's the world's longest cutting machine. That's Samin Steel machine, already mentioned as well, patented system. We have as well 2 machines, interesting machines in Keppelfels, Singapore. So we have here the pipe cutting machine, full automatic loaded and unloaded, and we have a full automatic slip-on flange welding machine. That's a column and boom system for welding in Germany. Robotic application for cutting in Saipem, Brazil. Saipem is a big player in offshore as well. Maybe somebody knows it. Siemens, Germany, high-speed train. Then reference customers in the offshore industry worldwide, quite a few, as well in the wind turbine industry. So I'm running out of time. I don't want to get too late. Now, what about this? So what is the idea about the cutting system? So this is a basic tractor. There are plenty of them on the market. That's a simple system. It's normally mounted by an operator for welding or cutting. It can be used as well with this application for welding, or it can be like here, that's a welding application and it runs around a big vessel. So now, how does this go with our decommissioning application or task? Well, the idea is here, we will call this thing Müller Opladen Terminator, and that's the picture one. So we would have hanging from a crane next to the offshore pile our base frame with the picture is not very accurate to what we really have in mind. The base will be roughly speaking 2 by 2 meter magnetic holder, and then we will have the track around it. This track will be magnetically going around the pile. So once this is in place, then we can actually start the cutting operation. As you can see here, obviously this is a little bit of concept drawing. So we would have high performance oxy-fuel cutting torch, which is fully automatic cutting around the pile. And so we can cut the wind tower into sections, whatever is the requirement. Obviously, if it's a faster and better operation to get the whole thing out of the sea as one, let's say 50 or 70 meter high tower, okay, then you don't need this application. But if it's needed for whatever reason, we can realize this. And you could use this with only one crane, as we would need, as seen already before, we would need anyway one heavy weight lifting vessel near the wind tower. So this crane can put our system, our terminator in place. Our system gets magnetically in the holder, and then the crane would be free to pick up the wind tower sections when they are cut. The features of the Müller-Opladen terminator, so it will work on wind towers with a diameter of 3 to 8 meters. Only one crane is needed in the whole operation. We can hang our terminator with that crane, and then we can as well hold the wind tower segment with the same crane. So the same crane is used. It's a completely remote controlled operation. We have as well on the terminator camera, so the operator can exactly see what the oxyfuel torch is doing. So that means at the end of the day, no operator needs to climb around the tower or being hoisted up there or doing anything. The terminator levels itself once the magnetic base frame is attached to the tower magnetically. The rails move around the tower automatically and attach themselves magnetically. The system for rails length adaptation to the actual tower circumference. So that means we have a certain space we can accommodate, because when we hook up the terminator to the wind tower, we will not know exactly what's the diameter at exactly this spot. So we can accommodate to that. And finally, when the whole rail is around the tower, it hooks itself on the other side with as well magnetic system, and then it cannot fall down anymore. So it's safely hooked, even if there's a power failure or whatever. The terminator, then the actual cutting tool, can move around the tower more than 360 degrees, so we can make sure that we definitely cut the whole thing off and we can lift it off. If it's required, we could as well adapt to the terminator a special welding equipment, and then we could weld as well the lifting eyes to the tower sections, like I said, if it's required. So that would be our terminator to cut on site, and at the moment the idea is over the water line, the tower into smaller pieces, whatever's needed and required. And then the other idea we have for decommissioning is what we call the recycling tandem. So we would have the big segments coming from the wind tower, coming from the sea, and maybe that would be installed in one of the ports. So I've seen already here presentations about several ports which are interested in this kind of operation. We have thought about a while what is the most efficient way to get these big or very big cylindric parts, conical cylindric parts, into smaller parts, which are maybe then truck transportable with a normal truck. If we want to transport anything with a normal truck, we have to cut it into segments of 12 or maximum 13.5 meters. So this is an application we would use 2 of our big heavy-duty column and boom systems. We put oxyfuel torches on the systems. We put camera systems on these column and boom systems. And the idea is that one operator can really run the cutting operation of 2 of these segments at the same time to keep costs down. So we basically load the segment, and then we have 2 cutting strategies, and we'll have to find out, and maybe it's as well depending on the actual application in the field. We can either cut the whole segment into long strips, even in the full length. That might be an option, or maybe we have to cut them down to 12-meter lengths, for example, before. And then once we have cut I would say the upper half pipe, then the column and boom system as well can go inside the pipe and can cut from the inside. So at the end, while the oxyfuel cutting process, and we have heavy wall there, is relatively slow, that is the point where the operator is enabled to run 2 of these cutting systems at the same time. Obviously, this is somehow software driven, and the advantages or the ideas are here. Double wind tower scrapping system, only one operator. That's one of the key factors to keep costs down. The operator does not need, while the oxyfuel cutting process, just to give you an idea, that's running around 500 millimeters a minute. So, all right, if I cut something which is 20 meters long, so one cut will take me 40 minutes. So obviously the operator has not to watch this for 40 minutes. It's an automatic process we control in all our systems. So the operator in the meantime can have a look what the other machine is doing, prepare stuff, and do things like this. The wind tower segments can be anything from 12 to 70 meters. I understand the maximum size of the things to be decommissioned is right now 70 meters. We're going to cut this with oxyfuel torches. The oxyfuel torch is on a motorized automatic column and boom system on rails. So the system, the actual cutting system, the column and boom is on rails and it's motorized and we can control where it moves. We have camera systems for easy monitoring on both towers, so the operator has a station where he can really kind of run both systems. The wind tower segments are sitting on protected and reinforced tank rollers. So it's a basic system from our, let's say, our portfolio, but we would reinforce and kind of protect us more for falling down things. They are sitting as well on rails and they are as well motorized. The segments get cut into the desired dimensions. So I don't know what is the ideal dimension. That might even depend on the scrap or steel mill where it goes to. So we could program that the dimensions are 12 meters by 1 meter, or maybe 12 meters by half a meter, or maybe 20 meters by, I don't know, whatever, 2 meters. That's not a problem for our system. That's just we need to know what the customer or the steel mill wants. There is no real operator programming needed. So that means once we load the thing on the rollers, we know then what is the length of the tank, of the cylinder segment. We know what the diameter is. If it's conical, what's the minimum diameter, what's the maximum diameter. In case there's any doubt or whatever, it can be again measured by the operator and then fit into the software. And then we just need to tell the system what are the segments we want to have after cutting. The rest goes automatic. Like already said, we can cut either, so we can set this either up that we put the tank rollers and the segment really on the rings, which are at the end, and we cut all the segments into small parts and we can still rotate. That might have certain advantages, but at the end then we would have to cut manually the rings, or we cut the whole thing. That would mean first the upper half into the desired segments, and then we cut from the inside the lower half into the desired segments. And like if there's at any point any hiccup with the cutting for whatever reasons, the system has as well a very easy, from the camera the operator can go on top on a view where he sees where the cut was interrupted, or where if he wants manually to add another cut from point to point, he just goes there with a joystick and says, from this point to that point, I want an additional cut. And then the machine, the system will execute it. So that's the basic idea for the recycling, scrapping activity onshore, where we think this would be a pretty efficient way to get this into smaller, more handleable segments. All right, I think I anyway overdid already my time. So thanks for your attention, and thanks for the opportunity to present something here.
Yeah, thank you, Jan. I think your presentation was very inspiring, at least the Terminator and the tandem. Thank you for this. And now we are in this Q&A section, questions and answers. So question to Dick. The vibratory installation of large monopiles is still a challenge. For extraction, setup effects have to be taken into account. Additionally, how realistic does the speaker see the possibility of complete removal of the XXL monopile, 10-meter diameter, 20 years of installation?
Well, so far we've seen that the scalability of the Vibro is working well for the installation. So similarly, we think the same thing will happen for the extraction as well. It has to be said that extraction generally is easier than installation, and that is mainly because during the installation you have to both overcome the shaft friction of the pile, but also the tow resistance, and the tow resistance is quite a determining factor for the success of installation. And with extraction, you have the advantage that you don't have to overcome this tow resistance, so you only have to overcome the shaft resistance. So generally, extraction is easier than the installation.
Yeah, thank you. I just try to be fast. So another question to Jan: does the Terminator work also subsea?
You remember we talked about this. So I would think that we can as well design a Terminator working subsea, but we would need from our side, from Müller Opladen, we are not a subsea company, so we would need a partner who takes care of all the subsea aspects on that. We are very innovative, and I think if we get in touch with the right partner for doing that, we can develop it and it will work.
Okay, thank you. So another question to Dick. Sometimes we are facing score protection inside the monopile when the pile was driving through the score layer during installation. Does score protection inside the monopile affect the monopile removal with your tool?
No, it shouldn't really. It basically is just another layer. If you look at it, it's just sort of a soil layer on top of the seabed. And particularly with the scour protection, it's normally loosely dumped. So the actual shaft friction that the pile has from scour protection is generally very low, particularly as it's right at the top of all the soil layers. So we don't expect any issues with that.
Okay, another question to you, Dick. What are the penetration depth of examples you showed? Is there a limit to penetration depth of monopiles?
The installation with the vibratory lifting tool, it's very depending on the soil layers. I mean, all the examples that we showed you have been sort of up to about 20 meters, 21 meters penetration. And generally, if you need to go deeper in the same sort of soil, you can use a bigger tool. That's the big advantage of having the modular tool, which we can just add more units to make it bigger and have more power. But yeah, larger penetrations have also been done in the past, up to say 50 meters penetration have been done in like oil and gas projects.
Another question to you, Dick. What measures are taken during the operation removal of the monopile to reduce the environmental damage caused by vibration and sound?
Well,
so especially the sound question.
Yes, I mean, obviously the head noise is a big issue, particularly with the installation of foundations due to the noise generated mainly by impact hammers. The big advantage of a vibratory tool for the installation is already that noise emissions are much lower than from impact driving, and the same is from the extraction as well. So yes, there is some noise coming from it also during extraction, and that has to then be weighed up against all the advantages of actually being able to take the pile out completely.
One last question to you, Dick. Have you gained any experience on friction increase after 20 years of operation, or how is it incorporated in the calculation for the force needed to be pulled out and pulling speed?
Yeah, that's a good question. There is obviously a setup occurring after installation, which over time becomes greater. And in experience, that can be overcome. There has been a very small offshore wind farm in Holland with 4 piles that has been in the soil for, I think it was 23 or 26 years. And the piles were extracted with the Vibro tool also very quickly. And I think that really showed that the effects of setup are there, but they're very negligible compared to the original soil resistance data that was taken when you first take the CPT data from the locations.
Yeah, thank you, Dick. There was one in the previous session. There were discussion regarding port capabilities and the different services offered in relation to offshore wind farm decommissioning. Are there plans to cooperate with different ports in order to cut the offshore wind farm elements close to the site of decommissioning before reuse or recycling? I think this is a good question, but now I have no one to pass it to. Maybe Jan can dream of something, but I think this is the wrong panel at the moment. Another one from a question to Jan: Can it also be used to cut rotor hubs?
I think that's obviously a little bit different cutting task, but we could apply the system as well to cut the rotor blades. It's just something, as you have seen in my presentation, this one thing with a natural gas drilling head, that's a pretty strange shape, let's put it like this. But while our machine learned the shape and it has sensors, and so we can cut that. So I think, yes, we can cut the rotor blades as well.
Okay, thank you. Maybe one last question to Jan. What would be the cutting speed for typical towers for this monopiles? Okay, that's not fair, the question. Maybe there we have to assume it's a 60 millimeter thick metal plate.
Yeah, it's so we need to see the fact that the cutting speed is obviously depending on the thickness. So now, on the other hand, we know that we can improve or get higher cutting speeds out of the oxyfuel cutting process by preheating. Okay, so generally, if you look just in a table, even if you take a high power or a high speed torch, you would find out that at 60 millimeters, this thing runs around 300 millimeters. So now, if we look into that as a bigger business and we design a terminator with a lot of special functions, I'm pretty sure that we can somehow integrate one or maybe even 2 preheating torches, play around a little bit with the gases and the nozzle and stuff, and I would think that we have a chance to get something out around 500 millimeters per minute. Anything more than that, I don't think it's realistic if you talk about 40, 50, 60 or even more millimeters wall thickness.
Okay, I think that is answering the question. Then Callum wrote, if I can clarify, what about the movement of the boat due to the seabed? Does it have to be steady? So according to Emmanuel, they have no wave compensating in their crane. So if the goods shouldn't hit the boat, then the boat should be steady. Otherwise, it's not working. Yeah, I think most of the questions are answered, and I would like to say thank you to Emmanuel, Dick, and Jan for their inspiring presentations. And I think we saw their interesting technology that can be used for decommissioning, and would now like to hand over to lunchtime.